Hey, this is Tom from everystepphysics.com. I'm going to show you how to do these test problems. I'm going to do number 6 on an actual test for you on the titanium with my programs installed. I'll show you how that works. We're going to press enter. This goes to the main menu here, physics. And because we're dealing in momentum and collision, you have to practice with my programs a little bit and know that that's collision. You can actually go to momentum and either one of them would go to the correct program, but it's collision or momentum problem number 6. So we'll go on to collision here, and next menu has a choice of words that the problems have. And when you choose the one that's in the problem, it'll take you to whether it's momentum or collision formulas. In this case, number 6 is a push because she's pushing the satellite away. Interesting thing is that this is usual in physics, of the trickery of physics and how they trick you in problems. Or in this case, there's an error. For instance, and the astronaut, it says, weighs 60 kilograms. In space, you don't weigh anything. It's weightlessness. However, you do have mass. And ironically, they're incorrectly called kilograms, both of them. Weight is called kilograms, and so is mass. But technically on Earth, when you step on a scale and it says pounds, you can change that to kilograms. But generally on Earth, it should be considered newtons. That's what the real weight is of anything on Earth. But that would confuse the public, so they use kilograms. But when I first looked at this problem, I'm going to divide her weight by 9.81 acceleration of gravity and come up with that figure for her mass to do the problem. But then that would be wrong, so I'd have to redo it and figure out why that was. But that's how they write these problems. Sometimes either the guy doesn't know what he's doing or what, I don't know. But anyways, we have to get through it, pass our class, pass the tests. So this one says push. I'm going to scroll down here to push, pushes. And I tell you that the difference between momentum and collision problems is that both masses are at rest. In other words, in a momentum problem, both masses are at rest and something happens. Something releases, something pushes, something ejects, something like that. So that you kind of know that with or without my programs, you know it's a momentum problem. But anyways, we're asked to find her velocity. And I'm going to enter her mass then incorrectly, as I say, but we're going to do it the way they do it in the problem. And it's 60. You have to press alpha before you enter anything to my entry, so I pressed alpha first. And I choose kilograms. And the space shuttle is alpha 350 kilograms. And she pushes it away with a final velocity for the space shuttle of 0.9 meters per second. And here's meters per second. We're going to choose number 3. And she's pushing it away from herself, so I would say that's going in the right direction there. We'll choose that one. I always show you what you've entered so you can change it if you want. I say that's correct. And in momentum problems, P2 equals the momentum of mass 2, and it's mass times velocity. So here's the formula, and here's what's, so the momentum of P2 is 315. Now P1 plus P2 has to equal 0, so P1 plus 315 equals 0, and so P1, then when you transcribe the 315 over the other side, it becomes a minus 315. And then we do the formula here. You write this all in your paper. We come up with a minus 5.25 meters per second. Now you notice the problem has 5.25 meters per second positive. Well, that would mean that when she pushes it, she's going to go the same direction as the space shuttle, which is not correct. When you push something in space, you're going to do the opposite. You're going to go to the left, and the space shuttle is going to go to the right, which the true formula for the problem states that and catches that. But in this case, it's 5.3 meters per second, so you just circle that one and get 100% on the problem, even though the answer that they have here is incorrect. Pretty neat. We'll go on to another problem.